This video is going to talk about system of equations and how to solve them. If you're given two different equations, you know that they each represent a line. Even if they're not in the conventional point-slope form or slope-intercept form that you're used to seeing, you know that they represent two lines. The question is, we want to know if these lines intersect, if these lines are parallel to each other and never touch, or if these two lines are actually, if these two equations are actually on the same exact line. To figure that out, we have a five-step process that we're going to follow. And we can do this all without graphing. Could we graph these and see where they intersect, or if they're the same line, or if they're parallel to each other? Absolutely we could. And with simple numbers, it seems like that would be the best way to go, but we want to learn with simple numbers the best way to figure this out without graphing, so that when we get to the more complicated numbers, we're ready to do it. The first step is to make sure that both of these two equations equal the same variable. So what I'm going to do is I'm going to have both of these equal y. So to get y alone over here, I'm going to add 3 to both sides, and I'll get y equals x plus 3. And on this side, I need to get rid of minus 2x, or negative 2x if you add the opposite. So what I'm going to do is I'm going to add 2x to both sides. So I'm going to end up with y equals 2x plus 5. Could you say y equals 5 plus 2x? Absolutely. But I'm going to write it in the more traditional way because that's more easily recognizable. That's step one. We're done with step one. We made the two equations equal the same variable. Step two is very simple. If you look at both of these equations, they both equal y. Let's go ahead and put a random number in there just for the sake of imagining something. Let's say these both equal 7. Is this true? Maybe. Maybe not. We don't know. So I'm just going to put that in a little thought bubble so we remember that that's not real, but we're just trying something for the sake of experimenting. If these both equal 7, x plus 3 and 2x plus 5, if they both equal 7, then what that means is that x plus 3 and 2x plus 5 equal the same number because they both equal 7, which also means that x plus 3 and 2x plus 5 equal each other. So what we just did is we just took these two equations and we made them equal each other instead of equal y. And that does work because y is going to be the same point in this equation. We're trying to figure out when these points intersect, what point will they be at. So we're going to assume that they do intersect. And we'll talk about what happens if they're parallel or if they're the same line in a minute. Step 3 is we're going to solve for the variable in this equation. So the variable is x, so we want to solve for x. There's 2x over here and there's only 1x here. So I'm going to subtract x from this side, and I'm going to get 3 equals 2x minus x is x plus 5. Now I still need to get the 5 out of there, so what I'm going to do is I'm going to subtract 5 from both sides. And I end up with x equals 3 minus 5 is negative 2. So I know that x equals 2. I know that both of these lines intersect somewhere on a point where x is 2. Now, there are two other possibilities for this third step. There's a possibility that you cancel out the variables. So let's say it was 2x plus 3 equals 2x plus 5. If that was true, when you subtract 2x from both sides, you would have gotten 3 equals 5. Because this says 3 equals 5, 3 does not equal 5. So if this were true, there would be no solution, which would mean that these two lines are parallel. And these parallel lines are on two different lines, and they're never, ever, ever going to touch each other. If you would have had something like 2x plus 4 equals 2x plus 4, subtract 2x from both sides, and you have gotten 4 equals 4, that means that these two are the same line, which means there's infinite solutions. Because this line right here would represent our first equation and also our second equation. They're the same line. We'll even pretend that's an S. So those are two other options. They don't end up being correct over here, but that's okay. Just kind of keep in mind that these are possibilities. Now, going back to our actual equation, we know that x equals -2. So for step 4, I'm going to take one of the equations, I'm going to take this equation, and I'm going to put in -2 for x. So I have y minus 3 equals, instead of x, I'm going to put -2. Now I want to get the y by itself. So I'm going to add 3 to both sides. I'm going to end up with y equals 1. And because x is -2 and y is 1, these two lines are going to intersect at the point -2, 1. And if I were to graph out these two equations, which I have no room for, I would find out that on the coordinate grid, they're going to cross at -2, 1. This is where they're going to cross, right there. And I did that without any graphing and without anything else. Let's see, actually I said I don't have room. Let's see if I do. So this is y equals x plus 3. So the y-intercept was going to be 3. Let's do this. Let's see if we have room just to kind of test this out. So if the y-intercept is 3, and we're going to, the slope is 1, so we're going to go down 1 over 1. So this line is going to look like this. The other line is going to be 2x plus 5. We're going to intercept at 5, which is not going to work. So we're going to fix our graph a little bit. 1, 2, 3, 4, 5. And then it's going to be 2 over 1, which is 1, 1, 2, 1, 1, 2, 1. Here is our second line. And you can see, even though they're not perfect, that they intersect at the point that we found following our steps. So to recap, step 1 was that we got the two equations to equal each other. That was to equal the same variable. Step 2 was that we made the two equations equal each other. Step 3 was we solved for x. Step 4 was we put that x into the equation. And step 5 was we found our coordinate points.